Collecting and organizing univariate data, exercise 3A. So the first thing we're going to do is go over some definitions. The first definition we're going to go over is univariate. Univariate data has only one variable. So in chapter 3 of the textbook, everything focuses on data that is just one variable. So univariate is basically data that has only one variable. Qualitative and quantitative. There are two main types of data, qualitative and quantitative. Qualitative data is data that is not given numerically. For example, favorite ice cream flavor. So if I were to ask every single student in class, hey, what's your favorite ice cream? Between vanilla, chocolate, and strawberry, right? Then the students would tell me, okay, yeah, my favorite is chocolate, oh, mine's a strawberry, mine's is vanilla. I would collect all of that data. I can't assign a numeric value to chocolate, vanilla, or strawberry. So that's what makes the data qualitative, because there is no numeric value assigned to it. When it comes to quantitative, that data is numerical. And quantitative data actually breaks up into two more subcategories. They can be classified as discrete or continuous. All right, so discrete and continuous. So like I said, now quantitative is numeric, and that breaks up into two subcategories. So with discrete, that's data that can be counted. For example, if I wanted to know the number of cars in a certain parking lot, I could go ahead and count how many cars are in a parking lot. I could count what is the average number of students in a classroom. So I could go to each classroom, count, okay, this classroom had 30 students, this classroom had 27 students, this classroom had 36 students. Then I could, find the average or the median or the mode of the data that I collected. So this is all stuff that can be counted. With continuous data, it's also numeric, but it's data that can be measured. So for example, if I wanted to know what's the average height of a high school student, height is something that is measured. We don't count what our height is, we measure our height. Same thing with weight. Let's just say I wanted to know what the average weight was of football players on the football team. I would have them step on a scale and we would measure how much they weighed, and then I would collect that data, so I have to measure it. Time is also something that's measured. Now time, initially you think, well, how is time measured? Well, we measure time through minutes, hours, days, years, and so forth. So that's how we measure time, is we have all of basically we use a clock to measure all of this stuff of how much time has passed. So that's also technically considered continuous data. Okay, the next thing is what we call frequency tables. So discrete and continuous data can be organized into a frequency table or a grouped frequency table. For continuous data, the classes must cover the full range of the values and they must not overlap. So this may not make sense at first, but the first example that I'm going to show you should clear up what a frequency table looks like, especially for continuous data. So let's go ahead and take a look at example 1. All right, so example 1. The ages of boys in a football club are. So they go ahead and they give us all of these ages. So this is all the data that has been collected. Part A, it says state whether this data is discrete or continuous. So again, because it's age, what we're dealing with here is something that's age is basically measured through time. How long from birth until today, how old are you? How long have you been on Earth, right? How long have you been since birth? How much time has passed? So at first, a lot of students think that this is discrete data, but this is actually continuous because we're measuring time. So this data is continuous. With our frequency table, if you look how this is set up, we have On the bottom end, this is 10. On the top end, there is, I believe, a student who is 16 years old, right? We see several students who are 16 years old. So we have from age 10 up to age 11. Now, it doesn't include 11-year-olds, it's up to 11. So it's basically X is less than 11. So that would include someone who's 10 and a half years old, who's maybe 10 years and 11 months old. I know we normally don't measure people's ages by years and months, but they could be 10 years old and 364 days, meaning that their birthday would be the following day. So this is basically all the way up until right before you turn 11 years old. So that includes all 10-year-olds, all 11-year-olds, 12-year-olds, 13, 14, 15, and 16-year-olds. So what I'm going to do with this frequency table now is I'm going to count how many 10-year-olds I have. And once I'm done counting, then I write it here in this frequency column. So once I count all this up, I find out that there are 7 10-year-olds between 10 and right before they turn 11. Then I go back to the data that I collected, and then I find out that there are 9 boys on this football club that are between the ages of 11 right before 12 years old. And I just continue to count. How many 12-year-olds do I have? 7. How many 13-year-olds? 3. How many 14-year-olds do I have? 4. And so forth. So all I'm doing is just counting how frequent it is for a 10-year-old to be on this football club, an 11-year-old, a 12-year-old, 13-year-old, and so forth. So that's how you create your frequency tables, is you have what you call your classes. So each one of these is a class. Notice that they're in equal intervals. Each one is 1 year apart. And then our second column is basically our frequency itself. Okay, so there's your assignment for today. It's problems 1 through 4. Don't forget to do your spiral review problems as well. If you need access to the answer key, go into Teams, go to class materials. There's a folder inside class materials that says answer key, and you'll find this answer key as it's the PDF that's titled chapter 3 and 4. So since this unit we're starting in chapter 3, you'll go to that chapter 3 PDF and look for exercise 3A.